Hello, everyone. We are back with another round of Turing Mock Interview series. My name is Jose, and I'm tech lead at Turing, and I'm from Montreal, Canada. But today, I'm not in Canada. I am in Lisbon, Portugal, and believe me, it's quite hot today. So today, I'll be interviewing Prabtash for the role of an experienced FastAPI developer. Okay, and sticking to the end because this interview will also blow your mind. So let's get started. Hello, Prabhash. First of all, how are you doing and how's your day doing so far?
Hey, Jose. I'm doing pretty good. The weather is pretty hot here as well. I'm speaking from Punjab, India, and it's hitting the high 40s here. But I think we have a bit of a rain going on outside today, so doing pretty good. The weather great, works great. Thanks for asking. How are you doing?
I'm doing great. Today's a sunny day, and believe me, I prefer snow. Okay. All right. So let's get started, man. So could you please introduce yourself and tell me a little bit about your background, okay, your professional experience, and then I'll take from there. I'll ask you a few questions about this tech stack, and then let's see how it goes. Sounds good?
Sure, sounds good.
Cool.
So I've been working as a Python developer mainly. Prior to that, I did my master's in computer applications. I started working out as a machine learning engineer, and I've been working mainly on Python because of the deep learning stack fits in together well. I have been working for 3 years now, and FastAPI has been my main tool to deliver all the machine learning models that I develop as consumable solutions to the clients.
Cool. And apart from FastAPI, do you have experience with another framework from Python, another Python framework like Flask, Django? Do you?
Yeah, I do. I have also used Django. I have migrated projects from Django to FastAPI. I have also likely used Flask for some of my college projects. So yeah.
Okay, so you mentioned have experience migrating Django applications to FastAPI applications. Is that correct?
Yeah.
Cool. I'm gonna talk about it later. So, could you please tell me a little bit more about some FastAPI project that you have been working on?
Sure. There was a pretty cool one which I'd love to tell you about. So we had this requirement where we had to process the user's selfies into portraits and apply neural style transfer. So basically, your selfie would go in and it would give out a portrait, a 16th century portrait of you, Renaissance style, or a Disney Pixar character that looks like you, or a sketch of you. And we use FastAPI to build this whole backend architecture where we had two microservices. One was to process the selfies, which would go into the deep learning module, and then that would give back the end result. So both of them were using FastAPI for the processing. The communication was really fast and asynchronous because of FastAPI's inherent speed benefits, and yeah, that came out great.
And I have a follow-up question. So you mentioned getting the face of the user, okay, the selfie, but it was built for photos or videos. Also, it was real time or post-processing.
It was built for photos and it was post-processing. It wasn't real time. We did have plans to deploy something similar to the device itself, but that would require a very robust device.
Cool. All right, great. So, and in my previous question, you mentioned that you have experience migrating Django application to FastAPI, right? Yeah. Now, first of all, what's FastAPI? Okay, and how FastAPI is different from Django application or even Flask application, Flask API?
So FastAPI actually takes a more Python. It's a web server that you can use to deploy RESTful applications or even develop full stack web applications. So the inspiration came from Flask, and Django. So here, if you see it on a spectrum, Django is like everything included, batteries included. That's how they term it. And Flask is like this minimal, very easy framework. FastAPI gives you the best of both worlds, where development is easy because anything you need can be added on through open source packages, and you can even replace them for your own packages, or if you don't like one package, you can switch it out for the another. And then you also have the ease. It's lightweight like Flask. It's faster because it inherently out of the box it uses asynchronous processing. On it beats Django by what I've read by an order of 2 in terms of every synthetic benchmark. So that's my understanding of why we went with FastAPI.
Okay, cool. So you mentioned they are FastAPI is like the best of both, right? Django and Flask. Yeah. Can we have UI? Do we have a UI for FastAPI, or it's just for API?
So there's two things. When you mention UI, one is that one of the very cool features about FastAPI is if you're just making a backend RESTful server, you would get a UI which would describe what each of your endpoints takes in as input, and what if you it's supposed to open API specification, so it will give you a UI to interactively view what your endpoints look like. And then you on the other hand, you have Ginger 2 templating engine also included, where you can render HTML pages and provide fast like develop it like a full stack web application.
Okay, so cool. In your previous answer, you mentioned that FastAPI can handle asynchronous tasks, right? And I would like to hear a little bit more about that. And my question for you is, what's the difference between WSGI and ASGI? What do you understand by WSGI and ASGI, and what's the difference between them?
Sure. So WSGI and ASGI are both standards for web server gateway interfaces. WSGI is inherently synchronous, whereas ASGI is the spiritual successor to WSGI, which is asynchronous inherently. FastAPI uses ASGI out of the box, whereas Django and Flask are slowly moving towards the ASGI standard.
Sure.
Okay, so the difference between the both is how they handle the incoming requests. The WSGI has worker threads, which are present, which are waiting for the request to arrive, and then when a request is arrived, it's handed off to a worker thread. But that significantly,
I mean, it's one thread, it's one new process for requests, or it will reuse the same process for many requests?
It will reuse once it has, for example, if all of the workers are occupied, it will wait for one of them to get free and then assign it. But the workers are a static number, and the common convention is to use twice the amount of CPU cores that you have as the number of threads.
Gotcha. Yeah, correct. And how about ASGI?
Yeah, so ASGI being asynchronous, it works somewhat like somewhat like we see in JavaScript. It has an event loop which picks up processes based on when they can be returned, and it can leave off certain processes which are, maybe IO bound or something to be picked up later. And the benefits based off of synthetic benchmarks, ASGI is like about 4 times faster than WSGI standards on many synthetic benchmarks, which include IO and database access and just raw processing.
And how do you test a FastAPI locally?
So I would use FastAPI's inbuilt test client. It's fairly intuitive and simple to use. You just basically add test underscore behind the function name that you want to test. You provided the dependencies. you write your test case in that, and that'll run.
Unity test, right? This is unity test, correct. All right, and okay, do you have an experience, okay, using FastAPI inside Dockers? What do you need to use FastAPI inside Dockers?
So all you need is a Python interpreter. So Python installed on any Linux Docker image. I use mostly the Python 3.8 or 3.9 Docker image that is already built. You can just pull that from Docker and start installing the requirements, the packages that you need to run your application, and give the last command as uvcon run on your host port and expose that port.
And one more question regarding this. Does FastAPI work with Python 2.7 or only with Python 3+?
I don't have experience with using it on Python 2.7, and I'm not sure if it does. It is a fairly recent framework. I'm not sure if they support. I think Python 2.7 did hit end of life by the time FastAPI came out.
Cool. And I would just like to call upon our Python developers here. So does FastAPI work with Python 2.7 or only for Python 3+ version? So let me know in the comment section below, and then let's see how it goes. So speaking about asynchronous, okay, let's stick with this. How do you create middlewares? What's a middleware?
A middleware is basically just a function which is kind of a wrapper around all of the processing that you do inside your API. So if you want to do something before the request comes into your function, or after the response has been generated and before it is sent out to the client, that's what you'll use a middleware for. A good example would be authentication middleware. So when a request comes in, you want to make sure that this is something that has access to, has the correct token to access this API. And the other one would be the request processing time being returned. So the authentication would happen before your business logic is ran, and the process time would be after it is run. Both of them can be done through a single middleware.
Cool. And how do we use middlewares in a request, for example? Let's suppose I have a middleware, as you mentioned, for authentication. How do we connect a middleware with requests?
So there are two ways we can create our middlewares. One would be create a function and just decorate with app.middleware and HTTP in the colon, or we could create a class, inheriting from Starlet's base HTTP middleware and implement the dispatch method. In both the cases, we would the function would expect a request object and a call next object, which would mean what to do after this middleware has been called.
Okay, and how can we use multiple middlewares?
So while creating the FastAPI app, you have to register these middlewares during the instantiation. So that's where you can include, and the order of these middlewares matter. So whichever one you put above would be the outermost wrapper or the first middleware to hit. So generally, it is the exception middleware that is the first one, and then your authentication, and then so on.
Okay, so they are synchronous or asynchronous. Let's suppose I have two middlewares, one middleware to check the authentication token, for example, and the other middleware is to extract the user and I don't know, use a map. Okay, let's suppose the request payload is too big, and then that function use only the email, and then I want to check this email, the user email. Okay, first I have check authentication, and then I have check user email if it's a valid email. Does it work synchronously or in parallel?
It works synchronously, but the underlying logic can be asynchronous. Middlewares, by definition, because we are providing them in a certain order, they are working in a synchronous manner. But if a middleware has a long-standing task which is not required for the step below, that long-standing task can run in its own while the next task executes.
And who decides that?
Decides what? Sorry.
Who is responsible to manage that? So if it will wait or it will run in parallel?
We can implement both asynchronous and synchronous middleware. So that's totally up to the developer how we want to.
Okay, great. So, and my next question is related to cores. Okay, so the cores middleware implementation are restricted by default, right? And so how to use the cores in cross-site context?
So this is a common problem everyone faces
Yes.
when we start developing an API. Okay, why can't I access this? So I have found a couple of headers that you can set in the cores that you can use in the cores middleware, which is basically accept headers, accept regex. So you can provide a regex for which origin you want to accept requests from, or you can provide the exact names also. There's another parameter for that. I don't exactly recall their names, but yeah, so that's how you can.
Gotcha. Yeah. And how does FastAPI manage dependencies?
So FastAPI has its own an inbuilt abstraction which can allow you to define what are the dependencies for a certain endpoint. So during runtime, these dependencies are evaluated, and that's when these are loaded. We can also mock these dependencies by using this convention called dependency overrides, I believe, and that's useful for testing features where or where you might have a cost attached to them and you don't want to test hundreds of times. So yeah.
Cool. Have you ever heard about Pydantic?
Yeah, I have actually used it.
Do you have experience with Pydantic?
Yep. I do use it.
Okay, cool. That's cool. So, what are the benefits of using it?
So, Pydantic is a library which allows the serialization and deserialization of input requests. It converts them into a Python class which can be used on per request basis, and then it also abstracts out a lot of the validation parts that we need to do on per request and gives us a very neat and concise API to implement those validations.
Cool.
We can also use it for object relational mapping. So you can use it for converting an input request into an object which represents a row in the database, and for all of that you just need to manage one class. So that's another neat thing.
What you mean is I can fetch the data from the database and convert that in an array of specific class, right? This is about the mapping, right?
Yeah.
I can convert a class object in object that I will insert in the database and vice versa, correct?
Yes.
What do you understand about coroutines?
So coroutines are like functions, but they are what facilitate the asynchronous programming part of Python. So coroutines were introduced fairly recently in a late Python 3 version only, and they are basically a function which is yet to be executed. So to be executed and evaluated. So to evaluate it, we need to use the await keyword. Anytime you run an you call an asynchronous function, it is going to return a coroutine object, and then you have to await it for it to evaluate into its final value.
Cool. That's great. And so that's actually triggers my next question. What are background tasks in FastAPI?
So background tasks are basically, it's a neat API provided by FastAPI, which lets us do tasks which are not essentially required in during the processing time of a request, but they need to happen outside of that time. So it's a way of taking out the unnecessary logic, which can add up to the processing time of a request, and doing that processing in the background when there are no requests or after the request.
Could you give me an example?
Yeah, so for example, if you use logging, right? Every application needs logging. So whenever you're logging out to a file, every time you do log.info or log.debug, it's essentially an IO operation that's happening, and that is synchronous. So those IO operations don't exactly need to happen when you are processing that request. If you just take out all of the logging and do it after the request, it serves you well as well. And in the process, you will end up saving maybe 1/10 of a second or 1/5 of a second. And these kind of times matter when you're working on an API which requires hundreds of requests per second.
Okay, so what I'm saying is it will flush the request, right? Return to the user and then proceed with IO operation.
Yeah, correct.
Cool. With this, we come to the end. That was my last question. So thank you for attending this meeting today. It was my pleasure to talk with you. And to everybody else, if you enjoyed this video, if you enjoyed this mock interview series, let me know in the comment section below what kind of mock interview would like to see here, and then just drop a comment there, and then we're going to make it for you. Okay, if you enjoyed this video, please give us a big fat thumbs up for this video, and check out our previous mock interview. There's a lot that you can learn, and subscribe to our channel if you are not subscribed already. And that's a wrap. I hope to see you all again, and thank you, Prabtaj, again, and have a good one. Take care.
Yeah, bye.